research. And if you can find, it is my thesis. If you're curious about it, it is on the shelf behind the screen. And let's begin. Quantum computing and how it can be used for machine learning. So I'll talk about computation inspired by physics. And then, can I talk?
Can you come closer, be louder?
I can try talking louder too. Yeah, I'll talk about physics-based computing, how it can be used to optimize problems, and how we can remove things from the projector so that
Computer, really is that computer?
Okay. All right. And then I'll talk about the D-Wave computer. D-Wave is a company in Burnaby, Vancouver, outside of Vancouver, British Columbia, which is the most famous quantum computer company in the world, and how its machine is the closest we'll come to solving these problems with quantum mechanics. Okay, so first, discrete optimization is a search problem. Let's say you want to schedule airline flights, and you have flights at different times. You take off from Seattle, you land in Miami, you have hundreds, maybe thousands of these things, and you want to find the best schedule with the fewest missed flights. And normally you could try all of them, but that's super hard. So what you want to do is write a computer algorithm to search through all the possibilities for you. You can define it with these math symbols. There's some cost function for getting it wrong, right? The cost is how many overlapping missed flights you have, and you want to minimize it. And this could take exponential, really long time, because if you have 1,000 flights, you could have, on the order of 2 to the 1,000 possibilities. So instead, we use some local heuristics. Think of it as a landscape, and water in this valley finds the lowest energy way to flow through it. So imagine that the landscape of all possible solutions for airline schedules is this valley, and we want to use physics to naturally find the lowest energy path through them, which is our solution of minimum cost. Fewest missed flights, biggest stock portfolio investment gain. Many problems can be formulated as optimization. So I'll go through this really quickly. Annealing is one way of solving it. That's when you start at a random point in the landscape and you let it roll around, but you could end up in a local valley, right? You could end up at the top of a small hill and inside of a canyon, and you don't know that the real solution is outside of it. So what you do is you heat up your solution. You make it jump around. But in a quantum computer can actually jump through walls. So you may have heard that quantum states can be in a superposition. This means that as you're searching, you don't have one searcher searching the landscape. You have many searchers that are like ghosts, and they can tunnel through walls. And eventually, where most of the searchers agree, when you finally measure your computer, that's the answer it'll give you. With high probability, it will be the minimum of the valley that you're searching for. Does that kind of make sense?
Yeah.
Cool. So computers used to be really big like this. Quantum computers today are as big as
this.
As big as this. So this is a picture of a field trip that I took to D-Wave headquarters. These are people-sized people. Behind them is a refrigeration unit, about 2 meters tall. Most of that space is to keep the instrumentation cool to about 20 millikelvin, which is literally one of the coldest places in the universe, and it's in Burnaby, British Columbia. You can get there from Seattle. It's not that far away. Google has used a D-Wave machine to label images. And recently, there are 2 computers in the US, one being operated by Google and NASA that is a refrigerator, and inside the refrigerator is this column. So this column is as big as my arm, and each stage is colder than the one above it. So that's the way thermodynamics work. You want to cool something that is slightly warmer than you are. And then at the end, this is where the chip sits. And that chip is the quantum processor, where these dots represent quantum bits. And only quantum bits that are next to each other can talk to each other. And this represents 128 qubits.
So the actual chip is very small, and all this space is occupied by the
refrigeration. That's right. It's mostly empty space inside. This is an example of a light switch game, which I probably don't have time to get into because I have 5 seconds left. It's been used to fold proteins, and I'm out of time.
Finish.
The other applications for it are to optimize radiation treatment. So whenever you have radiation for cancer patients, you want it to trace out a region which has cancer, but to minimize the amount of non-cancer tissue you irradiate. That's a hard problem because it's in 3D. When I was working at D-Wave, that was one of the projects they were working on, which is super exciting. Also protein folding for drug delivery. That's an optimization problem. If you want to train, if you have certain responses to certain drugs, given your genotype, your genetics, some drugs work better for you than others, and that's a hard problem. If you want to search through all the solutions, you can use a quantum computer to do that. Anyway, I'm out of time. Thanks for your attention. Let's move on to the next person.
Are those question and answers?
Oh, yeah, we have time for question and answers.
So does D-Wave sell like the computers themselves?
Yes,
Okay.
each computer costs $10 million currently.
Why don't they operate on like a SaaS model?
They do. So you can buy computer time from them. I don't know how expensive it is. I haven't tried. You have to submit a proposal to them, and they timeshare. So you can log in remotely. They call it the quantum cloud. It's the first quantum computer on the cloud. And you can submit problems and get the answers back, just like for old computers, you submit jobs and they run them overnight and you get the results on paper tape and Morgan.
So what is the architecture like? Is it like the machines we have? Like the machines we have?
Yeah, so right now it's hard coded, so it's as if we had an Intel processor which could only solve Sudoku. I mean, more useful problem than Sudoku, but it is hard coded to solve only one kind of problem, optimization problems. So it's not general purpose. It'll never replace digital computers for checking your email or going on Facebook or playing games. But who knows? I mean, people didn't think that digital computers would ever be useful for anything except calculating ballistic trajectories of missiles, or when people thought you would balance your checkbooks and keep track of recipes, and that's about it. Yeah, so the real applications for quantum computing probably haven't been found yet.
Does it actually work?
Does it actually work?
So their computer has been criticized heavily for, they have been criticized heavily for failing to demonstrate what the computer does. Is actually any quantum computer.
Right, so they've been criticized for whether it actually demonstrates entanglement, for example.
Yes.
So for demonstrating actual physical phenomena or characterizing error or things that matter to the academic research community.
There are certain algorithms where in computing you can improve the scaling with n substantially, for example, Schwarz algorithm, things like this. So
Yeah.
have they actually demonstrated that you do improve the scaling?
So for encryption code breaking problems, the D-Wave computer is not well suited. The architecture does not allow arbitrary connectivity. Like I said, it's good at optimization problems, running the adiabatic algorithm, which is a specific algorithm. It's not all quantum algorithms. For that class of algorithms, there are certain instances in which they demonstrate speed up empirically over a class of computers, regardless of whether they've demonstrated, like they've characterized errors or shown entanglement. So the things that are important to academic research community are not as important to people wanting to sell a computer that solves a problem. It may not be universally quantum in the way that most academic researchers would claim. That's the controversial part. It does something interesting. It's not clear how to characterize it. It's a whole new model because it's a thermalized ground state. It's not a perfectly zero temperature state. So it's a thermalized quantum Boltzmann distribution, and it samples from that. So that it does, whether that meets your definition of a quantum computer is, no one knows. It's a more complicated model.
Basically it solves optimization problems.
Yeah.
So can we solve any such problem?
Yeah, anything that can be formulated as an optimization.
And before I ask you, can it show that it can do linear search in
Say again?
linear search in order to
Again, that is not easily formulatable as a search problem. That's yeah.
Like a local search problem. If there's a search problem,
Yeah.
you want it as a local search problem, right?
Yeah, like what is the local minima of this problem? Yeah. So there are certain problems like NP-complete problems you may be curious about. Only
And the function doesn't need to be differentiable. So when you have mod x minus a, if I'm looking for a in this space, and I can vaguely formulate it as that.
Yeah, so it has to be something programmable into the computer. And yeah, so I think that means it has to be mostly differentiable. Like, it has to at least be within finite ranges, within physical tolerances. It's basically the same thing as differentiable.
You said something about the cancer cell treatment that you're talking about.
Yeah.
Is that basic optimization problem, or is that a little more complex than I'm grasping?
So I don't know the details of the problem myself, but I talked to someone who is working on that problem.
They're working on it, so it's not being done yet.
It hasn't been encoded to run on the D-Wave machine. They're still working on the encoding
Is it,
problem.
so do you know what happens with it in real life? In today's medical application, is something similar to that?
Yeah, so they have to run this algorithm. They have to simulate it beforehand. So the patient comes in, they do some kind of scan, maybe MRI, or and they try to capture the volume, the boundaries of the 3D tumor. And then they plan a treatment. They have irradiation beams that they have to aim using some algorithm to irradiate the cells with some certain amount. And their algorithm is to maximize the cancerous tissue that they irradiate and then minimize the non-cancerous tissue. So right now they run a classic algorithm. I think they do okay, but obviously it's human suffering, human lives, and so any amount to improve it. I don't know on the order of like whether it takes hours or days. That would be interesting. What's that? Okay. Yeah. Thanks, guys. Tyson,
I
like
saw
doing this.
I have one question, but I still don't understand like how the quantum computer evaluates the problem-specific stuff. Because
It's the same way that water flows downhill. So like that if you wait long enough, most systems will degenerate into their ground state. And so what you're doing when you're configuring your coupling these quantum bits to each other is creating this landscape so that the lowest energy ground state is the answer. It encodes the answer to your problem.
okay, so the logic is included in the configuration.
Yeah, which is your landscape. Yeah.
Okay.
It's as if you configured the valley to be the most efficient level route for a car to drive through it. And then you poured water into the valley, and then it showed you the most level river. So, cool. These are all great questions. Thanks, everyone. Tyson, would you like to go next?
Yes.
Thanks. Do you need to hook up your laptop? Yeah.
I can find it.
You did it. My demo works. And then the last 15 minutes.
That is very funny, nice.
Oh, I love those computers.
I know, so cool.
Sean, did you create a startup in 5 minutes?
What's that?
Did you create another startup in 5 minutes?
I did.
Yeah.
Oh, Sean, you're killing me.
Since I sat down on that couch, I did the whole thing.
Finish this while you're sitting on the couch.
Yeah, I just started to finish that project.
Seriously?
But still
Don't listen to
okay.
Tyson.
Okay.
Kissing me off.
Oh, fuck.
You can throw a chair. You can throw a chair through the window.
Wait for this one to come back.
Sean.
This one. This one. I'm having it.
David, dude, do you want to put your chicken in the oven or pan fry it?
I feel like he wanted to do that on the
No, I'm gonna pan fry it.
Okay.
So,
We can wait for a break in the box.
how easy was this then?
In 5 minutes, I will show you. So, I think
Guys, in a minute.
right?
Is that where we're about to go right now?
I mean, I think we.
No.
I can understand your code.
What?
I can understand your code.
In
I can replicate it.
5 seconds.
5 seconds, and I'm done with it.
How many knows your code by heart?
Just recite it to us, Tyson.
Yeah.
Just recite it.
I could do that.
0001 110. Let me count the ways.
You should be talking in quantum bits.
That sounds fancy.
Whenever I make videos, like louder.
It's not showing up too well.
I'll try and close this last line.
Wow.
I need to know
Oh, that's
that.
nice.
So this is my game. I did it all from scratch. So if your goal is to spend a good chunk of your lifespan working on a game, that's the way to go. Like screw libraries, screw engines, just do it from scratch. Great idea.
I'm just kind of
Wait, you look like in Scratch the programming language?
No.
Oh, I was gonna say.
If you want to spend your whole life plus your children's lives, then that's the way to do that.
That's pretty
So the way I always describe it is that it's real-time risk. You start off as the reddish planets, you can kind of barely see right now. And the goal is to take over the whole board with your color.
You're losing.
That means that you've graduated from a weak team to a strong one. So like if you see, you can't see it now.
And the Zoom feature is new, right?
Yeah. Just add the zoom thing. I don't know if it's a good idea or not, but
Good idea.
you like it?
So other paths between planets
What's that?
are other paths between planets.
Yeah. So like these guys with the doves, which you can kind of see, are the weak teams, and the weak teams don't fight each other, they only fight the strong teams. And that means that you took out a player.
So in essence, planets are fighting each other.
What can you actually do to
What's that?
what can you actually do to counter that?
Oh, you just drag and drop. It's like you select a planet, drag.
So you like put the graphics for this?
Yep,
Wow.
all of it.
Like a lot of challenging part of programming this.
Probably, like I got something that looked kind of like this, working really, really fast, but then it was just like all the details, like all the little design issues, all the bugs, getting the graphics into a refined state, just like all the refinements took a long time.
How long are you looking at this?
Like I'm nearing the 2-year mark at this point.
You don't do this full time, right?
No. I don't really do anything. Like if I work at a full-time job, it's not full-time, even close. So it's hard to say.
Tyson,
Yes.
what's the next step?
Next step is internet multiplayer. Before is kind of avoiding that, but now I think I could do it.
Do you think you're going to use Steam or separate SDL?
Well, it's not really a choice. Like SDL is a cross-platform library I use. So like let me avoid like all the like some platform details, like how to deal with input and sound and stuff like that. Whereas Steam is what distributes the game. So that's where you go on the web to actually buy it, if that's ever going to happen.
Yeah, so you're going to switch to Steam?
as opposed to what no one's selling it now.
Tyson, would you ever consider like organizing the web and then having sites like MiniClip post it and some ads?
Nah, too much work. I mean, Google does have an ACL, like native client, but I think they've already deprecated that. So other than that, it would just be too much work.
How much money would you charge us?
You guys would get the house discount, so that would be $19.99.
I would only pay $19.99.
I'm thinking maybe like $6.99 would be the price, but I don't know.
Any other questions?
Yeah.
Yeah, I'm like a marketing idiot. I have no idea. So I will give you that job.
Thanks, Tyson. Yeah. I should have been reading the stuff.
It is pretty good. My stuff's in there already. Oh, stove. Not the oven. There's a difference. It has my cooking cream.
Oh man, something smells spicy buffalo
And
wings.
you're plugged in. Alright. I'll take the VGA.
PG?
Well, or is the HDMI longer?
Yes.
Okay. That might work out
We show.
better. All right.
And go.
So a few months ago, I thought it'd be really cool to do like, let's say you're sitting at a restaurant and you need to find out like the sum of an infinite series, or you need to find the definite integral of something casually eating dinner. Wouldn't it be cool, instead of going to the website Wolfram Alpha, if you could simply have a contact saved on your phone called Calculator that you can text it anything that you'd ask on Wolfram Alpha, it will text you back right away the answer. So that's what I set out to do. So pretty much, have any of you guys heard of Twilio before? It's kind of hard, the word is kind of hard to say, and I'm probably pronouncing it slightly wrong. But like, Twilio, this guy. So this is what I'm using to do the text message stuff. Pretty much how it works is that you buy a number from them. It's about $1 a month to buy a number, which is a little bit, but it's still pretty affordable. And what they enable you to do is you can send it a request, and it will text a number. It will text someone a response, or if you text it, it will go to your server, say, "Hey, I got this incoming text message. How do you want me to respond?" And then what you do is you process that request on your server. And you usually call some APIs or something. And you send an XML response back, and the XML response is the actual message you want to reply with. So it's actually really straightforward. This is why I was able to do it with Google Translate. So I had the calculator on Wolfram Alpha done previously. But I was sitting at work today, and I saw that Paul had marked me down to do a presentation today about text message-based apps. So I thought, wouldn't it be cool to use something different? I used Google Translate. And so I'll walk through the code a little bit. It's pretty straightforward, honestly. So everything's called calculator and calculate because it was literally just taken from my calculator thing 15 minutes ago. But pretty much, you have requests come in. So to, from, the body, and the message ID. That's all passed into like a URL from, hey, how's it going? So that's all passed into a URL, just like any query parameters. So if you actually look, it kind of goes something like this. So I'm kind of giving away this, but if you look at the very top, it's just like from to just like that stuff. But that's what Twilio like makes the request to your server with. So it's actually really easy to kind of work with those kind of parameters. So you get those guys, and I made this utility that says log message. That's not really relevant. But here is my Google Translate API key, and then just for the API use. And then so the request body comes in with the %20 signs and everything for the spaces, so it's all URL encoded. And so we want to, or if it's not URL encoded, we want to put it as URL encoded. So we do that, and then we put our big query URL together. That just says like, hey, here's the body, the message, my API key, and everything. And sort of like pretty much those two things, and that's it. So I have the message of the like whatever you text it here. I'm going to translate this to English, and there's my API key. So I do pretty much run the query. I just make the API request, and they get the results back. And so the answer comes back as like the string that was returned from the JSON result. I won't go into the JSON parsing, but it's really straightforward. From there, I have this create message from body. That creates the XML document that to Twilio. This is the actual XML that says response message hello in this case. Okay, text. As a final thing before we do questions, there's a text. I put hola mundo, that's hello world in Spanish. But you can text anything. Idea or language, or like stuff like that, yes, I know Spanish or French. And it should text you back in English what it actually means. So if you text hola mundo, it'll say hello world in response. So if you guys want to try it out and let me know if it works, and you guys want to ask some questions while we do that, feel free. Yeah, go.
So the calculator thing that you told us about earlier,
Yeah.
when would you use that?
I literally have no idea. It's kind of a nice party trick to be like at a bar and you'd be like, hey, you want to know the sum of this infinite series? And be like, yeah, man, I'll pay you $1 if you can tell me in 2 seconds. And you text it to it instead of going to the website.
That happens to me all the time.
That's what I thought. That's me too. Or like, if you're some poor kid in India wanting to cheat on an exam, maybe then you could text it back too. But yeah. No, if you're some like, if you want to cheat on a test or whatever, and you don't have access to the internet, I guess theoretically you can send a message to it. But that is definitely not encouraged by my app whatsoever. Yeah. So, all right, I think that's my time. Any other questions, real quick? It works. All right.
Benito means welcome.
It works for Chinese too.
Nice.
No.
That's awesome. So yeah,
Thanks, Sean.
that's all there is to it. Thanks, guys.
Okay, what's going next?
I think you build us.
Bill. You go next. Yeah.
So what should I do? Should I talk about my project, or should I talk about like running some startup?
Oh, do you have tips about running a startup?
Yeah.
I think that'd be great.
Modules on startups.
You teach modules on startups? That's awesome. Yeah. I mean, that's my personal preference, but talk about the thing that you're
Yeah, talk
excited
about
about.
both.
So,
Yeah.
where do you want to project from? Do you just need a website?
Should I send you a spreadsheet? I mean,
It's on Google Drive?
Yeah. I'll
Okay.
just share it with you. What's your email?
Let me type in.
Send a copy.
PDF? Or?
PS. But this is like, you can use Mailbox or Gmail. All those three.
This house, instead of 2 houses, there are 2 capital deals.
Thank you.
Thank you.
Are you ready to present?
What?
Are you presenting now? No, we were presenting.
Didn't you know, Sri, you're presenting today?
Yeah, that's what we set it up.
You have to do a presentation?
Yeah. You just have to talk about something you think is cool. You have to show one picture and answer questions about it. That's all. I told you this morning, Sri.
Yeah, I
It'll
have
be
a
fun.
picture. But
Yeah.
I don't know what the presentation.
The house. Yeah, everyone's like good work. It's like here, but they're not really selling it. Different projects. It's looking at all the times of brain researcher. It's a variety of different.
Okay.
I don't know if there's a whole sound there.
The first house only has 7.
I think it'll be fine.
Oh, I didn't make any food. Can I make eggs?
Yeah, eggs would go great with my quinoa. You can just like fry them up.
I can fry it. It
Yeah.
feels good.
Yeah.
Do you have like a
I have house and I have house and annex.
Bluetooth connection?
Annex is what it's
I
called.
can like ship it.
Annex is what it's called, the new one.
Oh, you want to optimize it? I wouldn't mess with that right now. I
Oh,
think
okay.
I do, but
Work in
it's
progress.
not guaranteed to work.
Putting ideas, All of that.
Yeah, that's the name of the invention.
Yeah. And then it has a memory. Those are all like that one.
No, sorry.
Oh, really? They're balanced?
There are napkins when paper towels used to do.
Yeah. So, that actually really doesn't need to go. Housing options. Yes, they provide you
It's like old wood or something.
something from that. Really fancy. Or you have something.
But you can make money. You can take stipend.
So I actually think traveling the money is good. And it is vacation. And I give my then money doesn't make any so it doesn't the next day, right? You can after vacation, like, I was like, okay, I really want to get on but I'm working in Amazon. So I get a lot of everything Amazon, so like, I have little now on the everything that's a social mistake. And I think so many of the what happens is that they will they physical pattern options. And unfortunately, they face someone that really they got scammed out of money. So that was actually to a lot of people.
Nothing, or they got a place that was.
They just want to get it.
Oh,
Someone
yeah.
transfer, transfer.
Okay, it's kind of fragile. So
It's a very large number of people. That's insane. These are places where you do like four relationship brands on provide corporate housing.
no bump it too much.
Oh,
No bump it down.
can I like post it?
Do you want to make a full screen?
Like that
Yeah.
business is not, I don't think very much. You're always
Yeah.
just being
Oh, it's still
judged
not.
on their space, whereas
Yeah. Oh, why is it not?
and what's the price.
Okay, that's fine. I guess I just like
Community is a part where you can really add deep, but the house, that part, that's not part of this. It costs money. Okay, so you like charge more, but it costs more. So either charge more, it costs more, we charge less, it costs less.
Bill's gonna tell us about a startup
Yeah.
class that he helps teach at work.
not class, but like a incubator. Incubator.
Incubator.
Yeah. So I guess like I'm gonna talk about like launching your startup and how to gain like early traction and make sure your product is something that the market actually wants. So currently I'm studying business award. I've been always interested in tech, and I feel like tech has been especially like relevant to this topic because it's somewhere we can really experiment with ideas, change continually without placing down a lot of capital on a single development idea, and you're not like set. You can always modify. So recently there's a very famous quote called the Lean Startup. So I'm going to talk about the 4 ideas for that and the Lean Startup model. So like traditionally, a lot of people thought about launching a product. You bunker down inside a room or a research lab, and you work on it like perfect. You time out all the bugs and have all the features you want, and then you launch it. So the main problem with this like methodology is that it's very high cost. Like you put in a lot of capital into something that you might not even know will work inside the market, right? And there's a high risk of failure. If you fail, you invested all that money and time into that. was not good for the market. Even if the product itself was perfectly fine and like, all the features worked well and they were cool, it might not be what customers exactly wanted. It might not be really solve a major problem for them. So the key consideration here is to really understand like demands of the customer and like always researching their market and their needs, but researching their needs in a way that you find out the core of the problem instead of just saying, oh, the problem is this. So really, how do we find out the core of the problem? I see entrepreneurship as a way of like experimentation and putting out experiments constantly and using those experiments to slowly guide their idea or project towards like the general direction that you want. This way, you can eliminate wasteful practices. So we're going to ask questions, should it be built? Now it's not like asking, can it be built? Basically, almost anything can be built with enough time and resources. So asking, should it be built? Is very important. So how should we do this? Personally, I felt like the most effective method is to create an MVP, so like a minimal viable product that captures like the basic essence of your idea and really like has a core idea. For example, if you're building like a piece of complex software that's like HR management, perhaps your MVP can be some manual Google Forms where you replicate or try to replicate the idea of what your software will automate in the future. And you launch this towards like your early adopters or customers who will be most likely to use your idea from the start, so that they'll be the ones who will be more open-minded to experiment with maybe not a fully polished model, but something that they could try out, and they'll continue to give feedback on that process. And as you head along, you can see what problems and what specific needs and what use cases they give you throughout that like MVP, and that can help you guide you in the right direction for your like software development. So the software is actually headed towards the right direction from the end. Asking feedback is also key. So forming focus groups and going through this cycle constantly. You have your idea, you build something really fast, you code it, you measure the results. So measurement is also key. Especially with technology, you've got all these data about maybe how often customers download the product, how often they log on. And all these data is very quantifiable, so they really tell you what direction you're heading. And it's very easy to like access this data, right? And then you can learn from that, and then change your idea slightly and keep going. The more times you cycle through this, the more refined your idea will be. And here you can see like this is a very helpful chart. Before you can create like a 20-page business plan, just go through this chart and ask yourself like some of these key questions. And asking yourself these key questions gives you a pretty good overview of what type of market you're in and like which direction you're heading before you invest a lot of time. You can find this online on leancanvas.com. As you can see, like I highlighted like being able to list like your problems well, like the problem you're solving very clearly. And personally, I think that beginning with a problem is much better than beginning with a product and then aiming to solve a problem with that product. But of course, like you can always have a product first, and then try solving maybe one problem, and like you find that it's not really helpful to that problem, and apply that technology towards another use. So that's where I'm going to talk about my personal project now. My friend and I actually started like a social media app called London. Basically, what you do is you post onto a marketplace / like Facebook type of feed about events happening on your campus, so that you can organize groups to attend like movies, screenings, and soccer games and so on. So hey, soccer at Franklin Field, and people log in with their .edu emails onto this platform. So it wasn't very popular. Obviously, like GitHub came out and really like took over that. But we apply that technology actually. Now we're entering into a completely different space. We're entering into HR software. The HR industry and SaaS industry has been very hot recently, especially like feedback systems. And we've been talking to a lot of like investors and VCs and managers, and they all have this pain of being able to communicate feedback between like their employees, so 360-degree feedback, and in like casual ways, not just annual or quarterly reviews, but maybe on a daily basis, having that like message board and platform, and also reports on each individual. And that's what we do. Thank you.
Any questions for Bill? What was the name of that app?
So now I can show you.
Do it.
Yeah.
So it's called Slip Doc. I also recommend these two books for you guys to read, especially The Innovator's Dilemma first, and then The New Startup, and that's like a perfect series.
Why the order?
I think The Innovator's Dilemma gives you a lot of theoretical understanding of like innovation, and gives you a back to look at innovation and kind of trends in innovation, and like that like attitude. While Lean Startup provides like specific techniques and skills that you want to use. So that's why that order is helpful.
I'll add them to the house bookshelf.
It's definitely it's very helpful. It has been some of the most popular books for entrepreneurs.
The house people reader.
That's gonna get so long. You think?
Yeah.
How would we exit this?
I have an audible pretty strong. I use the lead side. The reason I asked about audibles is actually see through the lead side of it. I have a related to that.
It's cool, sorry.
Huh?
It's cool, sorry.
No knowledge for me.
What do you do?
Is it not loading? When it's happening?
And if he doesn't do this, he can do it otherwise.
Okay, so I guess I don't know why it's been cut off like this, but this is it. It's called Slip Doc. Way to get feedback in the workplace. So like if you really look at the VC space right now, SaaS platforms have been very popular. Investment for a lot of VCs, and lots of VCs are actually specifically focusing on SaaS. So if you really want more easy access to venture capital, that would be a way to go. On especially in Seattle, I guess enterprise solution has been key. Working at a SaaS company right now, in my internship has been great, learning like the business model and how to create a mean like sales machine there. So basically, our concept is how we can get employee. And
Sorry, your finger swipe is really misbehaving. You gotta be careful about back and forth.
yeah. So we're going to use like a combination of reporting and data to get understanding of how each individual employee is doing the workplace. And this is very helpful to have clear ROI so we can quantify our impact within companies, and that will help us sales in the future. So I can log in. We have basic stuff right now. So like as I said before, like we're building an MVP, that's an experiment, so that you know like exactly what kind of user interface people want. This user interface currently kind of sucks, but like you get a general idea of this platform. You can post like questions about workplace concerns or issues. Leave comments on these. You can upvote like issues. You can upvote issues that are a big concern in the workplace. You can set like privacy settings so that if you just want to talk to your manager, you can do so. You can set groups like maybe HR department and so on. This is just like one feature we built right now. I guess more important features would be helping individual employees and having that record, and combine those quantitative and qualitative stats in one report. Many people ask like how does it differ from Workday? I guess we're targeting SMB focusing on specific verticals, so that I can take that. Okay. Do you guys have any questions about this product development? Okay.
Thanks, Bill.
So,
So hold on. So the process that you talked about, the lean startup process,
Yeah.
like everyone that I've been exposed to, they get the test customers to pay.
yeah.
So there's a big difference between how a lot of people conceive of it and how this model does it, right?
Yeah, so I agree. We are also trying to get our test customers to pay. That's like $50 to $80 1 month. That really gives you like early validation and access to angel or early stage seed funding. Because that's really what justifies your startup, that people are willing to pay even for a crappy version of it. Let's imagine is really clear about how many people will pay, right? So I guess that's it.
Thanks, Bill.
And it's all searchable too.
Thanks, Bill.
No, no problem.
Do you have something you want to send me? Like
Nope.
a website? Nope.
So, I don't have a nice presentation to talk about because I really wasn't very well prepared for this. I don't even have very much completed projects, but I have some nice business exposure. One of the very valuable lessons that I learned about doing business, at least trying to do business in Bombay, was the importance of learning from cultures outside of your own. Something that was really cool was when I was in Singapore with my dad, we saw this earth-moving equipment that did something very differently from the earth-moving equipment that we used to manufacture in India. And that was when he really pointed out that it's extremely important to be able to tell those significant differences, become aware of them, and apply them back home. So using that methodology, what I did in my freshman and sophomore year was, I decided to get into making bubble tea in Bombay. So bubble tea in the QSR sector, which is a quick service restaurant sector, which is like fast food, like Dunkin' Donuts, pizza, rubbish like that, was really like expanding back home in Bombay. It was like blowing up. And there was a company called Mandover Donuts. So they came to India about 1 or 2 years before Dunkin' Donuts did, dominated about $300 or $400 million in revenue, like really doing well, all of that. And Dunkin' Donuts came down and could not compete with them. Moral of the story, QSR was doing really well. You could find an innovative solution, and get into it, and satisfy like a lot of the atmospherics, etc., like in the stores and other factors like costs, things like that. You could do really well. That was something I understood. Tech-wise, I'm illiterate. So all of you guys are smarter than me in this house. So the idea was in freshman and sophomore was to do something business-wise that would give me exposure to that instead of doing an internship where I learned technical skills to kind of get an understanding of just how hard it is to start a business. So sophomore year, what I did was, freshman year actually, I started doing a lot of research on setting up a bubble tea store in Bombay specifically. Now, bubble tea is a very niche market. Bubble tea, is everyone over here familiar with bubble tea?
Yes.
There are some people who aren't, that's all. So bubble tea is a very niche market in Bombay. Only people who travel block these. There's also a big demand for pancakes. So pancakes is something that people do know about in India and have tasted and have lots of demand. Bubble tea is not something that's very common. So the idea is to introduce something like an IHOP, Indian House of Pancakes, equivalent. And use that demand to leverage bubble tea. So the idea for pancakes I got from a different country. While I was back in 3 years, they slap a little bit of Nutella on a pancake or a crepe. They'd serve it to you for like a buck or something, which was really neat. It was actually really tasty. And it hadn't been done in Bombay. And it was also really cheap to do. So you could do that and kind of like use it as a stool to bring bubble tea in and introduce it in the right place. That was going to be good. And that was something that I understood. Like I understood how to make bubble tea. I understood how to make pancakes. It was pretty straightforward. Like coding none of that report we get. So I went home in the December before I decided to do this, and I started networking with restaurant owners in my very limited network. Show up at restaurants, make friends with the owners, figure out the rules and the licenses that are required to get open a store of my own. And it was a long process. It was pretty cool. In the process, I found that if you're trying to open a store, location is probably the only thing that's going to make or break your business in restaurants as quickly as in a few seconds. So just to give you an example, there was to introduce a concept like pancakes or something like this, where you're trying to target like the richer sections of Bombay, or trying to like the people who understand this a little bit more. You want to be in a place where they're located more heavily, and you want and where it is good. So a lot of factors go into it, like parking, how easy it is to park there, how late the place is going to be open till, will the building society let you stay, keep your shop open till late, will the cops give you issues, lots of factors like that. So this was the main road, and your shop was located here, and you were visible to the main road, lots of people, there's parking, all of that, successful. But if you were here, just in the corner, away from the main road, this is the lane, and they couldn't see your shop, but it was bigger, nicer store, you're 90% more likely to fail. So regardless of anything, 90% more likely to fail, 90. So many companies started to fail, including one bubble tea company who opened in the wrong demographics completely. He opened in some remote corner of Bombay, failed badly. They've been successful in 2-3 other parts of India. So they've been successful in Bangalore and the south and somewhere in between. But they screwed up really badly in Bombay somehow. So So what I'll do is really quickly wrap up. I use this same thing to work on the pancakes and bubble tea. I couldn't do it because 3 months was short. Navigating the legal issues of opening a store, take $8 grand a month in rent when they wanted a 10-year contract for prime location. It was a little beyond my financial capabilities. Those people willing to invest, but I didn't want to give her out of college this year. I use the same philosophy to do the equivalent of a one bus app that I found, which was done like the campus for Bombay. That's what I'm currently working on. The contract was just given out a few months before I approached someone else. And recently I found out they might cancel the contract. So we didn't have to. But yeah, I'm trying to make the public transport app for Bombay. So a lot of information really quickly. I should probably take the time.
No, that's great.
That's the question.
So what's the like bill side you need to understand the customer.
Yeah.
And all your customers refer to this again.
So what's the suggestion? No, they don't. My bubble tea customers follow bubble tea.
And then for everything.
They're well traveled, they're from our town. You read about them? No, but it's only to Korea. Actually, I'm from Bombay. Oh. No, but I understand what you mean, and it's really important for some customers. Like everything. Anything else about it? Okay.
Next. Okay. Lily, do you want to go next?
I'm up here.
Yeah.
So, sure.
Do you want to use your own laptop?
Sure.
Yeah. Right. Does it take HDMI? Don't die. Number one rule of the house.
Yeah, HDMI is good. Can I stand here?
Of course. No, Airbnb has a $1.5 million insurance policy.
Yeah, so if you're less than 1.5 million, you can die here. If your future earnings are greater than 1.5,
There's a lot of paperwork involved, guys. I don't want to do it. Please don't die. Number one rule of the house.
one more.
Where is this plug out? The other.
That's the plug in it is. Or, yeah.
I got this.
Okay.
You're good.
So it's like basically the caffeine level of 18.
So actually introduced me to matcha very recently. Yeah.
Can you make me bubble tea?
Matcha bubble tea is one. Yeah. No, matcha bubble tea is flavor. So fun matcha. No, when in India, like I want to mention some people to mention this. It's really far off. It has to be. It has to be. In fact, we're not even going to call it opportunity. Call it opportunity. No one knows what it is. They're going to confuse it. So, man, we're not actually to.
Okay.
So it's very different. So they probably like it sweet for some flavors and less sweet for other flavors. So the strawberry, the mango, and the strawberry, mango, and I think it was rose. Those are the flavors we tested.
No,
like
you don't want your face.
Everyone wants chicken, the spicy chicken, by the way. Go for it.
I don't know what it was like. I didn't test it.
Are we, okay. So I also don't really have a presentation. But basically, I'm just going to talk to you guys a bit about what I'm going to be doing this summer. So some of you guys, like when I tell you that I'm working for Girls Who Code, you guys are like, what's that? So I'm sort of going to give like a brief rundown of what they do. Basically, Girls Who Code is a summer, it's an organization that provides summer camp in computer science to high school girls entering their senior year or junior year of high school. And basically, like, it's trying to address this sort of disparity in the computer science and like technical fields where there's like, you know, there tends to be more men than women, which is really weird because like a lot, like in the 80s and like in the past, the percentage of women in the field is higher, but it has steadily decreased over time. So they're trying to ameliorate that. So just go over some like weird like computer science education facts. So basically, there's a lot of like room to improve in terms of encouraging minorities in the study of computer science. So not only is there sort of not as many women as there should be, but there's also much fewer like African American and Hispanic participation in computer science than there should be. So for example, there are 3 states where no females took the computer science examination, and 11 states where no Black students took the examination, and 8 states where no Hispanic students took the AP computer science test. Not listed on here is there are 2 states where no women, Black or Hispanic students took the examination. Ah! Okay, but Girls Who Code is really working to try and make that situation better, and they have a lot of data to show that they actually are. So Girls Who Code has only been around for about 3 years, and they've been growing really rapidly. So I think like the first year they offered the program, they only had like 1 or 2 summer camps, and these are day camps in large cities. And so the first year they didn't have very many. Second year I think they had like 100 students or something like that. And then this year they're going to have like 1,000. And in these couple years, they have gotten these statistics. So basically, like at the end of the program, they do a survey of these girls, and 99% of them, you know, have a good time and would like recommend it to a friend. And 94% of them said that they intend to concentrate or major in computer science, which is really striking because it's not listed on here, but like, I forget the exact number, but I think it was like 70 or something percent. Basically, like a ton of the girls did not intend to concentrate or major in computer science prior to attending the program, and they listed Girls Who Code as a major influence on their change of heart. And a lot of people criticize this 94% statistic after Girls Who Code came out with it. They're like, oh, you know, these girls finished the summer camp. They're probably just like feeling a lot of feelings, whatever. But then Girls Who Code followed up on that and found that 90% of the girls, now that they're attending college, actually do, in fact, major in computer science. So we know that the program really does have a strong impact. Another striking number is the fact that, so this summer there's like roughly 1,000 girls participating in the program, when nationwide about 4,000 students total take the AP Computer Science exam. So Girls Who Code is really working to increase the total number of people who are going into the technical field, which is something that we really need because I'm sure like many of us have heard, there's not enough people to fill a lot of the jobs that are coming up. And a lot of people were questioning like sort of the efficacy of the program. I'll wrap up. But basically, Girls Who Code put together an examination compiled of questions from introductory computer science courses from different colleges, including Stanford, Carnegie Mellon, the APCS exam, and Bryn Mawr. And they have found that the girls scored an average of 88% on that. So it really is, it's not superficial education. Yeah, so that's sort of like the impact they're making. I could also talk about how they do it, but whatever, out of time. Other questions?
Sure.
Yeah.
Do you say that the program is attracting people who are already like more girls who are already interested in CS? Because like the statistics are like almost too insane to be like you can make me think that like the program's attracting people who are already interested in CS and who would then go on. Do you find that they attract people who then kind of convert over?
So a lot of the there is an application process, but I think a lot of the girls like, you know, for example, like I did like 3 years of marine biology camp in high school, and like I'm definitely not intending to be a marine biologist. I think when you're at this age, you're just sort of exploring a lot of different things. So yeah, I think you do need at least like a cursory interest in computer science to at least apply for the program. But it's definitely like you aren't intending to major in it or something like that. Yeah, another thing about the girls who participate in the program is Girls Who Code. Programs like this tend to really attract like people with different levels of privilege. So like basically like oftentimes programs like this get kids who have like very active parents who are like, yeah, you need to be doing something this summer. And a lot of that, oftentimes that is correlated with like wealth and stuff like that. But Girls Who Code really strives to make sure their class like socioeconomic and racial distribution matches that of the local community. Each girl is given a laptop to work with over the summer, which sometimes they get to keep, but that's a secret, so don't tell anyone. But basically, like, it's a really big deal if you're like from like a low-income family and you have to share a laptop from like 2002 with like your 4 sisters. If you get to have one of your own and like keep stuff with.
How long are these kids?
Huh?
How long are these kids?
They last 8 weeks in the summer. 5 days a week.
What ages?
What ages? Students entering their junior and senior year of high school.
Only, is it exclusive? Are there other classes? Do they have other batches?
They only have one summer camp.
When did they start?
They start, different programs start at different times. I'm starting like a week and a half from now.
When did Girls
Who Code start? Like 2012, I think.
So they don't have plans to open it up to people elder than high school?
I don't know if they do. I think like right now what they're trying to do is like really make sure they have an awesome product in this area and then expand. A lot of people have asked for like programs in, for example, smaller cities or for younger girls, but they really want to make sure that this is up to par and delivering great results before they do that. Yay!
I think if we break, we will never go back to talks. Do you want to talk next, David?
Sure.
Yeah.
Yeah.
I will shorten it to 2 minutes. And if you want to talk for longer, you can go longer.
Yeah, I'm gonna be really brief. Like we're gonna rely on questions to go up to the full time here.
Do you need slides to be projected?
No, actually, can I use your teaching? I didn't school.
I just need to go like in 20 minutes. That's why I've been snacking throughout. How much we had to bring home.
Also, there's a micro.
Microwave.
How do you plug it into your computer?
Oh, it's a BGA2. That's what you mean.
So they're pretty, like, back you want my recipe? It's cooked, so it's probably cold
Those look really good.
Yeah. Wow.
Wow. Yeah. Okay. Let's try to finish it. We can still enjoy it.
Well, this is gonna have like no direction. There's escapes.
What's this and dessert?
Yeah.
This one. This one. Yeah.
Really interesting. I learned a lot from it. It's extremely unstructured. I think that just how much I underestimated how hard it was going to be. Like, okay, if you did so, I thought initially like this is not like tech, maybe this is something I can do. It's completely
Nice.
completely different.
Totally works.
We said we were having speakers, right? Amy didn't really understand.
And go, David.
Is this gonna work? Let me just. All right, we might be limited to that. Anyways, so I'm not doing anything too super interesting. Basically, I don't know if you guys know, I like guys in trying startups. I work at probably the largest company you can still call a startup. We have about 70 employees now, and we've been around for 2 years. But we haven't made any money, so that's why it's still a startup. They basically, I heard it's called 53. They work downtown, and sorry.
Snapchat.
Oh yeah, it's Snapchat. It's different. It's different. Yeah. Okay. It's a large startup. Yeah. Anyways. So yeah, I do. How do you guys know? I do some backend work there. It's not super interesting, but the app team has some super cool features that they just built in the app that I'd love to show for you guys. If I could get this, I'm gonna see if
I'm
I
gonna
can.
turn the computer on inside.
Boom. It's so turn the computer on side.
Yeah.
I feel like there's a better solution than that.
Turn the projector
There we
on. Oh,
It was almost there for a second. Damn. Okay,
I'm going to setting.
I'm just gonna hold my iPad then you guys can
yeah,
squeeze.
that's right.
This inside is rich.
Easy there, Chief. All right, boom. Basically, so essentially what they just built in, they use machine learning, and this is a stylus. It basically has, it's connected to the iPad via Bluetooth, and it has the same chip that you find, the same Bluetooth chip that you find in a Bluetooth mouse, because the 2 points on the end are actually switches, just like the 2 buttons you find on a mouse. Anyways, so basically they call it their, I think they call it their motion recognition engine. And it's basically this machine learning engine that when you select, you can open up a new, I'll be brief. When you open up this tool, this is called ThinkKit. It aims to detect what you're trying to draw. So I can, for example, if I draw, I'm really shitty at drawing, but if I draw a circle, it figures that I'm drawing a circle. If I do like a triangle, well, that was pretty bad, but sometimes it does. There we go, triangle, square, it does all this stuff.
Nice.
And then you also get like all the fill stuff, boom. It's all fancy. I don't want to go up too on here, but that's basically what the company's doing right now. So they're essentially, they have like a really fancy drawing app, and now they're using like data science and machine learning and all this kind of new technology that's emerging to basically make the best product possible to get ideas and put them down on paper. Yes.
Can you write it? Can you write that?
Yes, you can. They're actually working on text right now, so you can type as well. Right. Basically, the thing about stylus is there's a phenomenon known as parallax, and it's if you're ever in a car and you look over on the right side of the car and you look over at the person who's driving, you'll notice that they always seem that they're driving slower than they actually are because the needle's a little bit off the speedometer, and so it's a phenomenon known as parallax. And iPads have the exact same problem where the glass on the top has a certain thickness, and what's being projected behind it is a little bit below, and so it's not as intuitive to draw on an iPad or a touch screen as if you're trying to draw right specifically. The drawing as well, it's really hard to do. And so Apple just released in iOS 9. They just released a predictive technology, like a predictive engine, where if you draw, it'll actually fill out the line in front of where your stylus or your finger is. We've been testing it out at the office. It's pretty shitty, but we use a lot better. But they've been building in a lot of more complex functionality to try and combat that. The app actually it's huge memory requirements. It requires about 600 megabytes of
Apple's or yours?
This app. Okay. Brand. It's basically one of other than games, will be like the most intensive app you can run on your iPad. And the reason is because there's so much happening in that. And that's why it requires 70 people. Even though I wish I could show you more They got cool stuff like you can go back in time. Wow. Anyways, yeah, questions?
How can this be applied?
How can this be applied?
I understand like the drawing and shit,
Yes.
but like how do you manage like
The Red Other Marketing is a business tool. I can show you. I can basically. This might be the best showcase. So basically, I have two journals: hardware, software. Software was probably a little bit better. This is where I do all my flowchart planning.
Yeah.
Within, so I can do all my. I just jot down quick ideas like this. So I use this personally, and we use it at the office. The idea is you also be able to. It's basically faster than OneNote. I'm not doing as good of a job as selling as I wish I was, but that's kind of what the market. So rather than moving from like professional illustrators, because people can do hyperrealism with this app as well, because you can zoom, like really zoom.
Sorry, David, I got wrapped up.
Anyways, yeah. So that's it. If you want to talk about it, get it up.
Thanks, David. Okay. We have 10 minutes left before it goes.
That was his first clapping of the night, by the way.
Oh, nice, buddy. Yes.
All right. You got it. So
He's still to present.
I was the only one I had a clap for it.
okay. So who wants to go next? Is there anybody else besides me? Martin, Sri, Sapa.
so you guys have to keep presenting.
Good night, you guys.
Good night, Andy.
See you later.
Do you need you're going to use your computer?
That's fine.
Do you need what kind of adapter do you need?
No, it's and the stylus is actually.
What was David using? I need
VGA?
video display for that.
Luminia is good.
I'm gonna go right at 8, so I'm gonna eat real quick.
Okay.
I'll take 2 minutes. Bingo. I didn't get it. That's fine.
Is it there? It should work. So I always
Something must be either coughing or going the whole no doubt yourself. You should know you always never doubt my never doubt the soul. Sure, that confidence is like
Do you remember where I put my computer, by the way?
yeah.
Where is it?
Where's your mini display board?
I think
Do you want to use my laptop instead?
Which one seems to be spread?
Oh, right back.
Do you have a website that you want to go to?
I don't know.
Okay. What did I put?
No, that's good.
This is way cool.
Do you need a website?
Yeah.
The app is for iPad, but we have a guy whose job is to try and he's my supervisor. He's a jokes guy. No one likes Android. They're all Apple freaks. Fuck me. He owes me for my iPad.
It was so, yeah, you're seeing.
What are you working on?
What do you mean it was easy?
Well, I'm shaking
It's
fucking
still
delicious.
So good.
Holy shit.
It's so good.
And there's a good.
Is it good?
It's fucking delicious, like you said.
That's what I just want you to say it.
I might make this. No,
Hey, hi everyone.
that's not fun.
Hi.
Bye.
So I'm going to talk about first of all about programming competitions, algorithmic programming competitions, because there has been a lot of chit chat about it. Basically, algorithmic programming competitions are like you are so
some of you might have done an algorithms class in college, right? So there are algorithmic problems which you have to solve, and they are basically puzzles deriving mostly from discrete mathematics. So for someone who has interest in discrete mathematics, it's pretty cool. So I'm going to show you a quick sample of what kind of problems are there. So what this problem asks is, you have a dictionary, right? And the dictionary is ordered in a way that words that start with A come before words that starting with B. So that's the lexicographic order. But it assumes that the sequence of characters is A, B, C, D, E in this way. Suppose you are given such a list, like Revest, Shamir, and Edleman, and you are asked, give me the ordering of these 26 characters, which make this a dictionary order of names. All right. So in this case, we just need to have that R is followed by S is followed by A. Keep them in this order, and rest you could do anything. All right. So the brute force would be to try all 26 factorial possibilities, like 26 factorial possible arrangements, and check which one is true. But that is too slow. All right. So the way to go about it is you can build a directed graph here that of the 26 characters, that R comes before S. So there would be an edge from R to S, and then there would be an edge from S to A. And what you do in this graph is, if you know some graph theory, you can do topological sorting, and that will give you okay, nobody gives a fuck about it. Okay, so that would give you a possible ordering of the alphabets. All right. So basically, these are problems. They are super boring, whatever. The competition, the competition I attended is called ACM ICPC. ACM is Association for Computing Machinery, and ICPC is International Collegiate Programming Contest. So somewhere this says that this is like the Olympics of programming. Maybe, yeah, maybe they moved it. I'm glad they did. Basically,
No big deal. The Olympics of programming.
basically this is the team which won. This guy is badass. His name is Gennady Gayakovich. He's from Belarus, and he's 21 years old, or 20 years old, whatever, and he is the best ever in this field. This is a small field, but this is him. On the right side, maybe I should make this smaller. So do you see the tourist? He has 3,445 points. The second one has 3,077 points. The first guy, that is the guy who, like, he beats every fucking person there. So this kind of field requires a lot of hard work. So that's how it looks. Yeah. Yeah. So so every dot represents a competition that happens like at weekend. So if you were like getting less drunk on weekends and doing this kind of stuff, you would be holding a trophy. So. Yeah. Yeah. So I have. So this is the guy who used to be the best one before him. No prizes for guessing that he looks like Lionel Messi.
Russian guy.
Yeah, he's Russian. Peter Metricher. He Belarusia.
What Belarus?
Belarusia. The first one. So this guy used to be the god 10 years ago. All right. He looks a little like Leo Messi. Please, come on.
No, he does.
He does look like Lionel Messi. Yeah, so that's like a running joke. Lionel Messi and the other guy is Cristiano Ronaldo. Whatever.
Okay.
So yeah.
Wait, what's your score?
I thought this was Olympics.
I was yellow ones, and these are like in red zone.
What was your score?
The best I have been is 1900 something.
In the Olympics of programming.
No, on this website. So this was the result. You can look at the first one. That's his college. He solved all the 13 problems. This had not been done before. This happened in Morocco.
From which college?
St. Petersburg's National Research Institute of IT Mechanics and Optics. Russia. So MIT is here somewhere at 10th. And
Meanwhile, ranks higher.
UCB is at 6th. Well,
Welcome to IIT, bro.
Yeah, what happened to IIT?
IITs suck at this kind of thing. I mean, anyone besides Russians and Chinese suck. So the MIT team and the UCB team are also Chinese.
How did you jump to?
UW had a Chinese team, but
Wait, they had a Chinese team.
I mean, people who do their high school in China.
Yeah.
So
yeah.
it's a culture there. Oh, but
Have it ground.
So is this like indexing? Yeah.
what's the full form? What the Waterloo? 13th.
Hey, alright.
Represent.
So the medals were given till 12th position. Medals were given till 12th position. And you are 13th.
How did the University of Toronto do?
And were they even
Oh,
there?
UBC.
Were they even ranked?
No, they didn't qualify.
Yeah, they didn't qualify.
British didn't qualify.
Wait, what about UBC?
It didn't qualify.
UBC didn't qualify.
No, it didn't. All right. So my college is somewhere here in honorable mention. Yeah, whatever. Oh, yeah. So yeah, basically, so I'm done with these boring programming competitions. I could show you the kind of work that I've been doing at LNEI. Oh, it's a small demo. So basically, the work is related to natural language processing. So a lot of time, so what they are building is a machine which is like a competitor to Watson. Watson beat the human champion in Jeopardy. If you might know about it, it's an IBM product. So what they are building is it's called Aristo, and they want to answer multiple choice questions for fourth graders. So that's like, are you smarter than a fourth grader? They want to beat that. It seems so. So basically, if you suppose want to make a table of units and how to measure them. So you start with something like length in meters. The best way, I mean, a way to start with it would be like writing this table, or you can use this piece of tool and this means the 100 similar words to it. Okay, I tried to do a demo. I failed. Never mind.
Project you're working on something?
The thing that I made is not live right now.
Okay.
This is not my project, but this is what I worked so far. I'm using this to populate lists of CS concepts. So that would be like I'll be giving a table, which could be used to improve one of their software. And secondly, the approach that I have to do has to be like general, so it can be used for anything. So they are building a competitor to Google Scholar. Google Scholar is a search engine, so they want to do it better. Thank you.
Okay, Sri or Martin?
Over.
Yeah, I'm gonna stop it.
Martin, you're next. Do you have a?
I have to go.
No, I'm gonna send you.
Yeah. Did you? How did you send them to? By email?
Yes.
Which address did you use?
Just reply to the last message.
Oh. I don't know my password.
Oh, take everything that you
Okay, I don't know which address you sent it to. Sri, do you want to go next while we look for Martin's slides?
Do it.
Yeah, do it. Come on, we're all friends here. Tell me a website to go to.
You can access that. It's inside Amazon.
Oh, okay. Is there a public picture or something that will?
I have something. It's like that.
Okay.
You're not authorized to access.
Me personally, authorized to access.
Guys, any other chicken yet?
Yeah, it's really good. Oh. Here's some hot sauce. It's really good.
See you guys later.
Thanks for coming, Sean. Yeah, you're welcome. Soon.
Bye, Sean.
Come again soon. Come back. Come back soon.
Alright. Yeah, see you guys.
Bye.
Bye, Sean. Only you got pretty well. Pretty good.
Tying up, mostly listening to people's good idea.
All right, wait till I tell you.
Who's going next?
You are. Okay. Come on, Jane, you can do it. It's good for you. It's like eating your vegetables. You're doing exercise.
It's like
Then you
most,
tell people that you.
Do you wanna BJ?
do you have a
Do you have an HDMI?
HDMI?
Yeah, we got everything. There you go.
You scared me, you know that, huh?
What?
You scared me.
I scared you. Now HDMI? We can go back to BGA.
You're high.
Oh, yeah. This is a BGA.
There's
a BGA.
Yep.
BGA.
Oh yeah, I forgot to show you t-shirt.
There's
So,
no HDMI.
I got
there
this
is a
t-shirt there.
BGA.
Like a super.
It's a classic.
Has my college name on the back. So, some people get super emotional with these things, and they would give you t-shirts that have your country's name written over them.
Oh, what is this?
I was representing my college and my country.
Nice.
Bill has one in
Nice.
Canada.
Yo, there's my
Oh, this looks so good. Are these sweet?
Yeah, so international.
Should have some of that, some of that.
Or Canadians consider international and just.
Yeah, or it's worth it when we buy it, acknowledge it and see who it is.
Fuck off.
Yeah.
I don't believe that. Yes, don't believe that.
Yeah.
So what's the difference between Canada and America? You guys really have different words.
Major differences,
Like what? Free healthcare.
yeah, so if you
The safe.
so if you fall from bridge or paralyzed for life, you're covered.
Pretty sweet, you're right.
You can walk like push you off bridge.
Guys, free talking.
Listen, I can always push you off bridge. You're like you never think you're really push you off bridge. You don't know guys. I love you.
Okay. So it's one of the
Please respect yourself. Please. So,
Okay, so it's one of the thousands of projects that Amazon is working on. So I'm basically part of the content platform team, and the mini team within it is called Rapid, and we deal with digital transactions of Amazon, like the customers buy ebooks or Amazon Music or movies, something like that. And so when we buy something from Amazon, say a digital product, What happens after that? Why are you smiling?
Nothing, I'm not you give a presentation like that. Can you smile? Is that what happens when you give a presentation? You get distracted by someone beautiful in the audience. I like this.
Okay, so what happens when a customer purchases a digital product from Amazon? Okay, so suppose I'm buying an ebook and with a credit card in United States. So that is called a transaction, and my job is to create samples of those transactions so that it's easier for the testing team. What is he trying to do?
Nothing. Can you focus?
Just do your presentation.
We're getting distracted. Can you focus on your presentation?
Okay, so my job is to create samples of those transactions, and for
Extend it by 3 more minutes.
You can answer questions.
Okay, our question is, can you finish the presentation, please? So
that's my project. I have to create samples for those transactions, like the use cases for the testing team. That's it. It's a mini project. So basically, I have to create a web service which will extract those transactions from the transactions database in Amazon S3 and filter them. Like suppose we have samples. Suppose we have transactions.
S3 as in like the AWS service?
Yeah,
S3?
yeah.
But yours customer service side, your customer payments.
It's like all those transactions are stored in the S3.
Okay. And S3 is fast though, so you can get it however quickly.
Yes, and like there's a workflow. Like there's a purchase, then it goes to the finance department, the accounting department. So in between that, it will go to my web service, which you can see that is the transaction repository. So that is my web service that I'm creating. And so it goes from there and it will get filtered as like if there are samples which are already there in my database will be stored in DynamoDB, which is the other database Amazon. And so they will be stored there. And whenever a new sample gets created, comes in, like suppose there is no transaction, like someone from Malaysia is buying an MP3 with say PayPal. So that is suppose is a new transaction. Like there's not been a transaction like that. So that will be a new sample, and I'm supposed to store them in DynamoDB in those tables that you can see, the sample configuration table and the other table. And the testing team, they will be collecting those samples for their testing.
Very good.
Thanks.
Okay. Now, so just as a testament to paper, so in the time that Shrita did that presentation, I recreated her entire thing in paper, and it looks way better.
What?
So,
Say that.
yes, so next, just as a testament to the quality of paper.
And die!
And you did
And
that.
I did that in like a minute.
I did that in 1 hour!
Yeah, that's my point. That's what
Who told you to do 1 month?
Thanks.
That's a good demonstration.
No one wants
This, your marketing team will fucking kiss you for. That's the way you market a product.
Thanks, Sri. Aren't you glad I made you do
That's
this?
actually really
Of course.
Yeah.
I like to hear your presentation.
I have questions. I have questions.
Yeah,
Wait, I have questions.
sure. Oh, okay. Do you want me to stand and
No,
answer
not
your
right now,
questions?
not right now. Always like pause right.
Yes,
I will ask you. I will ask you.
Sure, go ahead.
Do they let you know this? Like this is free for everyone?
For everyone.
Fuck off.
So
that's
that's
not-
why
great
I
job.
made it. That's it, 'cause I was
Yeah.
$50.
Wait, I $50?
Thank you.
So I could order it now.
See?
You like 600? Stylist studio.
No, the stylus doesn't know.
Why do I need a stylist?
The stylus just built it, so for the stylus of race, my broken right now about the race, you can use like this.
So hold on, there's other stylists out there. Could I use a cheaper one, like big
It
scales?
wouldn't connect through Bluetooth, and so you would get all this functionality. You would get to do this and stuff. You wouldn't get, this is a nice stylus. It wouldn't also, the thing with this stylus that makes it different is the reason that they can use the predictive technology
Are
is
you gonna
because
buy this before you?
they can give me, they give me.
So if they didn't give you one, will you buy it?
Yes.
Are they going to take it away?
They can get broken. But anyways, but the thing is like,
You think you can get a second one?
there isn't really, there's a low capacitance relay in here to toggle the end, so the end can be on or off.
What is this?
This is $50, and a nice one is $60.
What's the difference between the
It's made of the local natural wood chestnut. It looks really fucking gorgeous. Did you Google chestnut?
What? No, you're not sharing this. Oh, what?
It's beautiful. So that's wood. This is
I think this one looks so much like this one.
I'll give it to you.
No, because so I wasn't simple to be honest. Like, you just did that right now. Like taking house glass is gonna be like fucking simple.
It's actually testing. It's a fish.
So why don't they allow you to type in boxes and create
Yeah. You have to really
type in just
push it in there.
No, you can't take those.
That's what we're doing.
not with the styles of people. So like I know like you can like select the box and you type in, recognize it, you can type inside.
That's what we're doing.
It's gonna be pretty fucking sick.
You know what I did?
Weird.
Yeah, shit, you fucking
Every single
really?
Yeah, so you can switch
I
to
realized like it's
He's such a smart thing.
no, because like
She agrees. It's
Yeah.
like really simple.
no, because you always end up on Facebook.
Martin's on. You've got 2 minutes.
And then it's
2 minutes.
right?
Okay, so
I feel like you should give it for
Listen to this.
That was a talk I gave 2 years ago. That happened to the sense and make things worse to Germans. So let's look at pictures.
Whoa.
So I'm working in particle theory. So what you
it's not changing.
it's not that's not good.
all
Notice.
You want to know what time it is?
my extended positions.
Yeah.
So what you're looking at is the subnuclear structure of matter. So if you look at things, then first you see atoms, then you see nuclei being made of protons and neutrons, and yeah. So that's what I'm interested in. So let's skip all that. There are 4 interactions in nature. One is gravity, which keeps the one 4. Then there's electromagnetism, which seems to electrons. Then there is something called strong interactions, which binds protons and neutrons together into nuclei. And then there's something called weak interactions that is responsible for radiative decays. I'm working in the field of strong interactions, so that deals with atomic nuclei. So that is in charge of the standard model of particle physics. These are the all particles that you can find in nature, and on the right there you see the Higgs boson that was discovered 3 years ago now, and now the picture is sort of complete. What builds us up is essentially the up and down quarks on the left, and also the electron on the bottom left corner. So then you might also have heard of things like dark matter and dark energy, which are weird stuff that we don't really understand, and which teach us that the standard model can't be the full thing, so that there has to be something else in particle physics that needs to be understood. Then there's 2 strategies, so you can search for things beyond that. Either you shoot things together with extremely high energy, like at HC in Geneva, and you want to produce new stuff. And the second strategy that you can follow is you look at circles at lower energies, but at extreme precision. So you measure something extremely accurately, and then you also try to calculate similarly accurately in the standard model, and you look for a difference. If you see a difference, that can be a sign of the physics you want to discover.
What is low energy mean?
That is a fair question. So yes, it's a bit difficult to face this in everyday terms. So imagine you have a proton as one of these particles, and this becomes what we say relativistic at some point, which means that has energy that is comparable to its mass. Remember Einstein, that mass is energy, and once it gets energy similar to its mass, then it's quite relativistic. Low energy means non-relativistic, so below that. Yeah, so let's skip all this. So I just want to give you one example of this. So there's a quantity called the anomalous moment of mu. The Here the normal is magnetic normal of mu. That is one particular property of one of the elementary particles that I showed in the chart earlier. And it's a very interesting quantity because you can, on one hand, measure it extremely precisely. So that is the first number up there. And you can also calculate it extremely precisely. That is the second number there. And you see that most of the digits agree, but then in the last digits, still significant, you see a deviation. And that is about 3 sigma or so. So this could be a hidden as something else. And actually, in order to improve this, there is one experiment to measure this for a factor of 4 better over the next years. Actually done here at UW.
You said there's an experiment to do what?
To measure this quantity. And yeah, what I'm working on is improving the theoretical calculation over there. And the diagram that you see on the right one is one of the ingredients.
So when you've improved this and you've completely measured this, when you've mastered the measurement of this, what can you do exactly?
So I mean, at the moment it's at the edge of significance here. So you see this discrepancy. You don't quite know what it is. It could just be statistical fluctuation, but it could also be a sign that there's something physics. So now if you measure it more precisely, the experimental error bar will shrink. We try to calculate it more precisely than the theoretical error bar will shrink. Several things can happen. Either the discrepancy goes away, there's something there, could be still involved. Then the discrepancy could increase to above what we call 5 sigma threshold. So 5 sigma is the threshold for discovery. So if you have a discrepancy at this one, then you know definitely that there's something there. Or it could just happen that the discrepancy stays at the same level, but with small error bars. That would be the worst case scenario. Then
So what are some possibilities if the discrepancy remains?
Yeah, do you want my favorite theory
of
beyond the standard model of physics? It could be anything. So one of the candidates is supersymmetry. That is one theory where we postulate that in addition to every particle in the standard model, we have another particle with different spin assignments. Okay. That would be one candidate.
Anti-particle?
What anything?
Well, different spin quantum.
Yeah. So is the anti-particle the same thing? No, anti-particle is just, that is already covered in the standard model. So that is not new. It's just opposite charge assignments.
I didn't understand what you said.
So
I'm sorry, I don't understand the physics law, but you said, what did you explain before right?
I just counted one possible.
So what was it? Like simplest, stupidest way to say it.
It's called supersymmetry.
Supersymmetry. It's as stupid as you can get it.
And so the basic idea is, so I showed you this chart of elementary particles. Doing these scores on these scores aircraft. And what you postulate essentially is that you add a copy of this chart and call all these particles superparticles. Okay. And the difference is just that they have different properties assigned, and this property is called spin.
And this taps into what he was talking about.
Yes. So he asked you change the spin.
Okay, so that's what makes the testing possible, because you aren't waiting, like you said, to go through all the possible calculations.
Well, I asked, well, so usually if something you calculate theoretically is different than what you measure physically, that could be due to the error in your equipment, the noise in the earth. And so if you decrease the error of both of those and there's still a gap, then that means that your model is wrong and you need to do something fundamentally different is true about the model.
So that's actually what we hope we define. So we actually want to see a difference so that we can find something. So if we just confirm the same model, that would be most of the case measure. There are hints, energy, method, that we know that there's something else. We want to find true this what it is. That is really cool. That could be that.
But they haven't found any super symmetric particles.
But there's an old joke that we already found half of them.
Like why not exactly?
Legendary.
Really?
So like, the
Okay,
super
I didn't have.
You need to find the other ones that are
Whoa. I'm sorry, I've done math in 3 years now. My math is doing percentages and shit.
It kills that physics conference.
Very nice.
Yeah.
So, for the supersymmetry, So isn't that so? Wouldn't that explain how black holes exist? Because like would the like opposite things exist in the black hole? No, never mind.
Something to
Fuck off.
Don't bring it up. So
David, did you also recreate his presentation?
good job.
This list is
All right.
That should be.
No, wait,
Thanks, Mike.
yeah, we can check.
All right, guys. Yeah, me. Yeah. Let's go.
Yeah, there's always some dessert that I brought. You can answer dessert. And one more thing, somebody asked me how the well do IITs perform at those competitions.
Yeah.
I don't want to rephrase what I said.
David, no,
No, you should listen to me.
Wait.
I want